Hi ladies and gentlemen. Today we're going to be talking about solving one-step addition and subtraction equations. This is called a one-step equation because there's only one operation that's listed here that we have to undo to be able to solve for our variable. So usually the instructions will say solve for x. All right, so our first one, x plus 15 equals 21. Most of you can do this mentally and know that x has to be 6. But to show this mathematically and correctly, you're going to be using the strategy as you get into 7th and 8th grade. So since this is an equation, I know on the left-hand side of my equal sign, this side has to equal that side. So some number added to 15 has to equal 21. To figure out what x is, we're going to take 15 away from the left-hand side. To keep this equal, I want to take 15 away from the right-hand side as well. So now when I simplify it, I have some number, I added 15 and I took 15 away, so that gets rid of those 15s. We're left with just that number, x, on the left-hand side. And on this side, we're going to perform this operation here, 21 minus 15 equals 6. So I can say that x equals 6. We're going to check our equation. It's always a good idea to substitute that number that we found for x back into the original equation. So I'm going to start with the original equation, x plus 15 equals 21, and I'm going to substitute 6 in for x. And the objective is when I do this addition, will that equal the 21 that we originally said it should? And 6 plus 15 is 21. So this left-hand side equals the right-hand side. That means the value of x being 6 is correct. It checks out. Let's move on to the middle one. X plus 2 3/10 equals 9 1/10. All right, so we have some number that when we add to 2.3, it's going to give us 9.1. We're going to use the same strategy that we did over here, which is the opposite operation. So again, I'm going to split this to the left-hand side and the right-hand side. I'm going to take 2 3/10 away from the left-hand side and on the right-hand side to make both sides equal to each other. It's kind of similar to working with fractions. Whatever you do to your numerator, you must do to your denominator if you want to make an equivalent fraction. So same concept here. So I have some number that we added 2 3/10 to. Now we're taking the 2 3/10 away. That means we're left with that original number of x. And over here we're going to do the subtraction. We do have to do some borrowing. And we end up with 6 8/10. So that means x equals 6 8/10. Let's do the check here as well. So we have x plus 2 3/10 equals 9 1/10. And we're going to substitute 6 8/10 in here, plus 2 3/10. Now it's common for a lot of students to just assume or not do the math to see if you add those, will it be 9.1? So I'm going to do that addition on the side just to be sure. 8 plus 3 is 11, and 2 plus 6 plus 1 is 9. Decimal point comes down, so yes, this sum is 9 1/10. And this is 9 1/10. So that means the value of x is 6 8/10 because this left side equals the right side. All right, and the last one over here. 12 plus x equals 39. The x is in a different position. Sometimes this whole 12 plus x could be on the right-hand side and 39 on the left. That's okay. We're going to follow the same kind of step here. Right now we are adding 12 to x. So that means we're going to take 12 away so that we get x on its own. And we're going to do the same thing over on the right-hand side as well. Oops, sorry. All right, so we added 12 to x, then we're taking that 12 away. So I can cross those out. We're left with just x on the left. And 39 minus 12 gives us 27. So we have a value of 27 for x here. Let's do the check to be sure. 12 plus x equals 39. So I'm going to substitute 27 in. And just double checking. Yep, these two add together to make 39. So it checks out, the value of x is 27. If I make a mistake and I find, let's say for example, I found that x was equal to 24 by accident. I did a mistake with my subtraction and I substitute 24 in here instead. When I go back to do the check, I notice that adding those two together gives me 36 instead of 39. So that means this left side does not equal the right side. That means either my original answer is incorrect, which we know it is, or I made a mistake in the check. So I got to go back and look at my work one more time if this check does not check out. All right, let's move on to some subtraction problems. Our first one here is x minus 28 equals 57. We're going to use the inverse operation of addition to solve these. So we have some number that we're taking 28 away from. So that means I want to add 28 back to it so that I end up with just my original number. If I add 28 to the left-hand side, we do have to add 28 to the right-hand side. So we're left with just x on the left, and 57 plus 28 is 85. So that means the value of x is 85. Again, let's do a check. We'll substitute 85 in. X minus 28, will it equal 57? So 85 minus 28 equals 57. And I want to do the subtraction on the side just to be sure, instead of just assuming it'll check out. 15 minus 8 is 7, and 7 minus 2 is 5. So yes, we end up with 57 and 57. So the value of x is 85. We just proved it. All right, on to the middle example here. X minus 6 4/10 is equal to 10 4/100. So again, we're going to use the inverse operation. I have some number that I took 6.4 away from. So that means I want to add 6.4 back to it so I can get back to x. Those two will cancel out. And I want to add 6 4/10 on this side as well, because we did the same thing on the left-hand side. So to keep it equal and balanced, we have to do the same left and right. Right, so on the left-hand side, we have just x. And over here, when I add my whole placeholder here, we end up with 4, 4, 6, and 1. So that means x is 16 44/100. Let's do the check to make sure. So I have x minus 6 4/10. Will it equal 10 4/100? So we're going to substitute in 16 44/100 and subtract 6 4/10. We want to know, will it equal 10 4/100? So I'm going to do that subtraction on the side here. Yep, 10 4/100 equals the 10 4/100 we said it would, so it checks out. All right, over on the side, we have subtraction. 16 minus x equals 9. So this is a little different because the order here has changed. So we have 16 that we're taking x away from. So I'm going to do something a little bit different here. I'm going to add x to both sides, right? Because I have 16, I took x away from it, then the value was 9. So I'm going to add x instead, inverse operation. So on the left-hand side we have 16 because these x's cancel each other out. And on the right-hand side we have 9 plus x. Right, so now this looks like one of those addition problems. We're going to use the inverse operation of subtraction here. Since x and 9 are being added together, we're going to take that 9 away. And that means I want to subtract 9 from that side as well, from the left-hand side as well. So this x on the right comes down, and 16 minus 9 is 7. Okay, so let's do the check. Shouldn't have added this little line here. That's going to bother me. Okay, 16 minus x equals 9. 16 minus 7 equals 9. And I know when I do that subtraction, 16 minus 7, it is 9. So the value of x is 7 here. All right, so I'm sure the most common question I'm going to hear is, do I have to show my work in this way? This year I'm not asking you to show work this way. I'm not going to take points off if I give you a quiz. But you should know you have to use the inverse operation to be able to solve for these questions. When you get to 7th grade and 8th grade, you will be working on two-step equations, like something similar to this. 2x plus 7 equals 15. So to undo those steps, to undo the addition, undo the multiplication here, you would have to undo the addition first and then undo the multiplication. And it is helpful to organize your work in a way such that I was showing before. Just so that whoever's looking at your work can understand what steps you took and what the order of that was. Eventually you're going to get to multiple steps, something like this. And maybe that equals, let's say, 12, right? Something like that. So then,
Mr. Nash, please call 2271. Mr. Nash, please call 2271.
There is a certain order of undoing all of these operations, the addition, the multiplication here, this multiplication, the division. So again, showing your work in a systematic way is very helpful. All right, we will speak during the video conference call. I'm sure you're going to have some questions about the format of this, and speak to you soon. Bye.